Hello grade 12s. In this video we will be looking at answering questions on circles. We have done all of the theory in the previous videos, so these videos are pretty much just referring to the types of questions they can ask you in your exam. And there's quite a few things you need to know here that wasn't discussed in the textbook or in the previous videos. So important that you take some notes on this, please. Now, the first question they could potentially ask you when it comes to circles is, where does a point lie in terms of a circle? So this question simply asks, if you are given a point and you are given a circle, where does that point lie? Does that point lie maybe inside the circle? Does that point lie on the circle's circumference? Or does that point lie outside the circle? And the only way to really answer this question is to look at the radius of the circle. So very simply, the way it works is it works like this. If you go from the center of the circle to a specific point, and the distance between those 2 points, the center and that point, is less than the radius, then obviously the point has to lie somewhere inside the circle. If I again go from the center of the circle to another point, and that point, for instance, lies the exact same distance as the radius, so in other words, the distance between the center and that point is equal to the distance of the radius, or the length of the radius, then that point must lie on the circumference of the circle. Then lastly, if a point lies a bigger distance away from the center of the circle than the radius, then that point lies outside the circle. So let's just do the examples and you can quite quickly see how this works. First things first, we are given a circle and the equation of the circle x minus 2 squared plus y minus 3 squared is equal to 18. That means the center of that circle, and we'll call it D for instance, is the point 2, 3. And we'll put it on the diagram. So, the radius is then equal to the square root of 18, which if you put it in simpler surd form is going to be equal to 3 times square root 2. So again, that point is exactly square root of 18 or 3 square root 2 units away from all the points on the circumference. So any point that has a smaller distance than that radius is inside the circle. Any point that has the same distance must be on the circumference of the circle, and any point that has a bigger distance than that is going to be outside the circle. So let's quickly work out these distances. So we're going to work out AD from the center to point A. We're going to say 2 minus 1 squared plus 3 minus 5 squared. And I'll type that into my calculator quickly. Is then equal to the square root of 5. Now it's difficult obviously to compare square root of 5 to 3 times square root of 2, but you can then go and you can round it off. So let's round this off to 1 decimal place, which is going to be 2, 2. This square root of 18 is then going to be 4, 2. So immediately you should be able to see this distance is quite a bit smaller than the radius. So because this is smaller, that point lies within this circle. So A would be somewhere, probably somewhere over thereabouts. But A then lies within the circle. It's inside the circle. Okay. Next one, then if I go from B to D, I can go 2 minus 5 squared plus 3 minus 6 squared. And that's going to give me 3 square root 2. Which, if you think about it, 3 square root 2 is exactly the same distance, which means because BD has the same distance as the radius, it means B is a point on the circumference of that circle. So this is potentially going to be somewhere over there. B will then lie on the circumference of the circle. So that's how you prove a point lies on the circumference of the circle. And then we can go from D to C. And that's going to be 2 minus minus 2, so 2 plus 2 squared, plus 3 minus 7 squared. So it's going to be 4 squared plus 3 minus 7 squared, and that's going to give me 4 square root 2, which if I press the SD button so we can compare properly, is going to give me 5, 7. So 5, 7 is obviously bigger than that 4, 2 units, which is the length or the distance from the center to the circumference, length of the radius or that distance. So that means this point then lies outside the circle. And that's probably going to lie somewhere over there. So now we can see, looking at the distance between the center and the point, we can then determine does it lie inside or on the circumference or outside the circle. So that's just how to determine where a point lies in terms of the circle. Right, so that's the first question. Next question. How to determine the points of intersection between a circle and a straight line. Now, in this particular example, they've given you a circle, x squared plus y squared is equal to 9. Now, we haven't really seen this version of the circle equation much, but it shouldn't actually be complicated. It should be fairly straightforward and easy. This version of the circle equation says that the center of the circle is going to be the point 0, 0. Because I can rewrite it like this. I can say that's x minus 0 squared plus y minus 0 squared, which, if you think about it, is then equal to 0, 0, or the origin is the center of the circle. So don't get a fright if you see an equation like that. It's quite easy. It just means that if there's no bracket, like a complete square bracket, then it just means that that particular x or y coordinate, in this case, the x and the y coordinate, 0, 0. Okay. So they give you the equation of the circle. They give you the equation of a straight line. Straight line OM has got the equation y is equal to x. And then they say Pn is a tangent to the circle at M. Now the first question here is they want you to write down the length of OM. Now this is very, very easy and straightforward. And the reason this is so easy and straightforward, hopefully you can see this, is because from O to M, because M is a point on the circumference, this is equal to the radius. So always try and spot when they're giving you the radius, because if they're giving you the radius, they've already given you the answer by giving you the equation. Because the center then is obviously the point 0, 0, and careful, the radius squared is equal to 9, which then means the radius is equal to 3, so therefore the length of OM is then equal to 3 units. Now, the next question. The next question is to determine the coordinates of point M. Now, I'm fully aware of the fact that M is the point of contact of that tangent, but they haven't given me the equation of the tangent. They've given me the equation of that radius. So they've given me the equation of the radius, and they've given me the equation of the circle. So because I don't have the equation of the tangent, unlike one of the previous examples that we did, we can't solve the tangent and the radius simultaneously. I have to now go and I have to solve the equation of the line, in this case that y is equal to x, and the equation of the circle simultaneously to find where the two cut each other. So I've got x squared plus y squared is equal to 9, and I've got y is equal to x. Now you can't just simply set them equal to each other. You have to go and use your grade 11 technique of solving the equation simultaneously, which means substitute that in there. So we're going to say, for instance, y is equal to x, which means I'm going to substitute this y is equal to x into y over there. So x squared plus x squared is equal to 9, which means 2x squared is equal to 9. So x squared is equal to 9 over 2. And then please remember, when you use the square root, please use the plus minus. And I can then simplify that saying x is equal to plus or minus, and the square root of 9 is equal to 3 over square root 2. Now, obviously, we have that plus minus, and the reason we have the plus minus is if I extend that line down, the line would not only cut the circle up here, it will also cut the circle down over here. So that's why we have the positive x coordinate, and we would have had the negative x coordinate. But I'm not going to be interested in the negative one in this case, because M is located in the first quadrant. So I'm only going to use the positive one. And I'll sub it back into this equation, which means y is then also going to be equal to, let's just state x is then equal to the positive 3 over square root 2. And by the way, if you type that into your calculator will rationalize that denominator for you. So it's going to say 3 square root 2 over 2, or to 1 decimal place 2, 1. And then this is then also going to be 2, 1. So point M is then the point 2, 1, 2, 1. So that's just how you find the points of intersection between a straight line and a circle, is by solving them simultaneously. I will be doing a more complicated example than this one a little bit later on, as part of one of the past paper questions. Okay, so pretty straightforward. Now, the next question is quite a strange question. It has a little bit to do with that question that I discussed the first time, which says, how do I determine where point lies? Wow, can't speak. How do I determine where a point lies in terms of a circle? This one talks about intersection of circles. So circles can either intersect in 2 points, or they can intersect in 1 point, which means they touch externally, or they can intersect in no point, so there's no point of intersection. And they really do love asking this question where they say, if you were given these 2 circles, can you tell me, do they intersect at 2 points, do they intersect at 1 point, or do they not intersect at all? Now, this one is actually fairly easy and straightforward to answer. Please don't complicate it. It has everything to do with the radii of the 2 circles. Now, I know these 2 circles seem like they're equal, so it seems like their radii equal, but please imagine that these are not identical circles. This one might be a little bit smaller than that one, just so that their radii aren't exactly equal. So what you need to see is you need to see the following. If I draw a straight line between the 2 centers of the circle, then obviously the first circle's radius will be located from there to there. And the second circle's radius will be located from there to there. Now, we'll call the first radius over here, we'll call that R1 for the first circle's radius. And we'll call this one R2 for the second circle's radius. Now, you should notice that the distance between the 2 centers is going to be less than the radius of the first circle plus the radius of the second circle. So that's how you determine whether 2 circles intersect at 2 points or not. If the distance between the center is a smaller distance than the sum of the 2 radii, because if I put that pink line next to that green line, I've put the pink and then the green, you'll notice that the sum of the radii is definitely going to be bigger than the distance between the 2 points, the distance between the 2 centers. Then you know they intersect in 2 points. If, however, we have this situation where if I draw a straight line between the 2 centers of the circle, and then this is again radius of the second circle, and this is again the radius of the first circle. Now, in this case, if the distance between the 2 centers of the circles is equal to the radius of the first circle plus the radius of the second circle, this means that the 2 circles will touch or intersect in 1 point. So they touch each other. And then lastly, again, if I draw a straight line between the 2 centers, then you can again go and see that's the radius of the first circle, that's the radius of the second circle. So in this case, the distance between the 2 centers will be greater than the sum of the radii. So if the distance between the centers of the circle is greater than the sum of the radii, those 2 circles will not intersect each other. They will not have any points of intersection. So this is just if they ask you a question about whether the circles intersect or not, that's how you do it. You simply go and you work out the distance between the 2 centers, and then you compare it to the sum of the 2 radii to make your decision whether the 2 circles cut, touch, or don't cut each other at all. Okay, right, next question. This question is also becoming more and more common, and it specifically has to do with when circles touch the axes. And they love saying this. They love saying you draw a circle and this particular circle touches the axes in 1 point there, the y-axis in 1 point, and in 1 point there, the x-axis. Now, this is very important, and the reason it's so important is whenever a circle touches a straight line, that straight line is a tangent. And we learned in the previous video that the tangents of circles are always perpendicular to the radius. So if I put the radii in there, then this will be perpendicular, and that will be perpendicular. So please, people, remember, if the axis touches the circumference, then that axis, in this case the x-axis right there, becomes a tangent to the circle. So it's perpendicular to the radius. And the y-axis right there becomes a tangent to the circle, so it's also perpendicular to the radius. Now that is very important to remember, but it even makes it easier sometimes to do this question. And the reason it makes it easier to do this question is the following. This, if you'll notice, is the radius of the circle. That's the radius of the circle. And because this is perpendicular, the radius is perpendicular to the axis, and that's perpendicular to the axis, this point right there will be the point R0. It will be the point R0 because the radius runs over there, and then obviously because it's on the x-axis, it's 0. And this point right there will be the point 0R. Because again, the radius runs up from 0 up to that point. And then even more important, the center of the circle will have the point R. Because if you can figure out what the radius is, you'll know exactly what that point is. So if you had the knowledge that the radius of this circle, so you say, for instance, the radius squared is equal to 25. Therefore, the radius in this case is positive 5. Remember, radius is always positive. So normally we'll put a plus minus there, but in this case the radius is 5. Then we know for a fact the center of the circle is the point 5, and we'll know that the x-intercept of that circle is going to be the point 50, and the y-intercept of that circle is going to be the point 0.05. And then obviously if the circle doesn't touch there in the first axis, if for instance it touches over here in my fourth quadrant, sorry, not first axis, first quadrant, if the circle touches here in my fourth quadrant, you then just have to go and make sure that you make the coordinates negative. So please remember, radius cannot be negative, but if you had to draw the circle over here in the fourth quadrant, then your x-coordinate will still be positive r, but your y-coordinate will be negative r. Or if you draw it here, it's going to have an x-coordinate of negative r, but a y-coordinate of positive r. Or if you draw it over here touching, it's going to have an x-coordinate of negative r and a y-coordinate of negative r. So I agree the radius can't be negative, but the coordinates can be negative. So please just watch out if it's in different quadrants. So this is very, very useful information. Right, so there's an example that they asked in the IB supplementary paper of March 2018, where they said, question 12, two different circles pass through the point T, which is the point negative 2, 4. So there's point T, the point negative 2, 4. And both touch the x and the y-axis. So they say there are two circles that can do this. And logically speaking, the first circle has to go through the point like this, touch there, and that's the first one. That's a tiny little circle. But the other one will obviously then go through there. I'm very bad at drawing circles, but hopefully you'll see what I'm trying to accomplish here. There'll be a second circle that will kind of go through that point T as well, and it will touch over there, and it will touch over there. So we've just had the discussion that if I look at the center of this circle and I look at the center of this circle, I know that the center will reflect the radius and the radius, just like over here it will reflect the radius and the radius. So it really doesn't matter where that circle is, the center is going to be the point negative r, because remember we're in the second quadrant, so r will be negative over here and then positive r over there, because this is a tangent, so this is going to be the negative radius length for the x-coordinate, and then the positive radius length there. Same thing there. That's also going to be the point minus RR. There we go. So now at least we have the center of the circle. And we also have a point on the circumference. So we did this in the first video about circles on how to find the equation of a circle. So we said if we want to find the equation of a circle in the form x minus a squared plus y minus b squared is equal to r squared, we need to have the center and we need to have a point on the circumference in order to find the radius. Now I know this is not exact, but we can substitute this in. We can then go and we can say, right, the x-coordinate on the circumference, careful, that's the x-coordinate on the circumference, is -2. And then minus the a-coordinate of the center, which is minus r, so it's plus r squared, plus the y-coordinate on the circumference is 4, minus the y-coordinate of the center, which is r, is equal to r squared. Now the moment I substitute that in, I realize I've got an equation with one variable. It's an equation with a variable of r, so I can now actually go and I can find the radius of the circle. So I can go and I can expand this. Let me just go down where there's a little bit more space. So minus 2 squared is going to be 4 minus 4r plus r squared plus 16 minus 8r plus r squared is equal to r squared. There we go. So if I collect this, this is going to be 2r squared minus r squared, which is just r squared. This is going to be minus 4 minus 8, so minus 12r. Sound like a pirate at the moment, r, sorry. And then 4 plus 16 is then plus 20. I can factorize saying it's r. That's going to have to be 10 and 2. So minus 10 and minus 2. So r is equal to 10 or r is equal to 2, which makes sense because we did draw a tiny little circle which clearly has a radius of 2 and a much bigger circle which clearly has a radius of 10. So now we actually know the centers of these circles. The center of the first circle, because r is 10, is going to be the point minus 10, 10. The center of the second circle is then going to be the point minus 2, 2. And the radius squared is going to be 100 over here, and the radius squared is going to be 4 over here. So this circle is then going to be x minus 10, so x plus 10 squared, plus y minus 10 squared is equal to 100, because that's equal to r squared. Or the second circle is going to be x minus 2, so x plus 2 squared, plus y minus 2 squared is equal to r squared, which is equal to 4. So a super complicated question actually becomes very easy and straightforward if you just know this simple little bit of information about when a circle touches the axes. By the way, it's not always going to happen that a circle touches both axes. It is quite common that a circle will touch one axis. And then you're going to have to adjust this slightly, obviously, because if the circle doesn't touch the y-axis, if it moves slightly over, then you know the y-coordinate of the center will still be the radius. But then the x-coordinate of the center will no longer be the radius. So you have to adjust. But very, very important information to have. We will continue, obviously, with these questions on circles in the online lesson. Thank you very much for listening.